Hello, this is Ms. DB. In this video we are going to continue solving systems of equations, and we're going to get a little bit more complex with these problems. We're going to solve by multiplication. It's also called elimination, but unlike in the last video where you could just add them together to eliminate, we're going to have to use some multiplication before we can eliminate one of the variables. So let's look at this first problem here. It says list the number needed to create the additive inverse so that the terms have opposite coefficients. So here's an example of an opposite coefficient. If I have 4x, let me get my pen here, the coefficient of 4x is 4. The opposite coefficient would be a negative 4x. These would be opposite coefficients. Another example would be, let's say we had negative 3y. The opposite of that would be a positive 3y. Those are opposite coefficients. So in each of these problems, A, B, and C, you're going to answer the question about making the terms have opposite coefficients. So let's look at A. It says 2x minus y equals 20, and then 3x plus 2y equals negative 19. So on our x terms, our coefficients are 2x and 3x. So the coefficients are 2 and 3. On the y terms, we have negative y. That's the same as negative 1y. So let's put a 1 there. And then we have a 2y. So we have to decide which term would be easier to eliminate by multiplying so that we get the opposite coefficients. Well, the x's, we could multiply both of them by a number so that we would get opposite coefficients. So it's possible. We could multiply a 2x by a 3, and that would be 6x. And we could multiply 3x by a negative 2, and that would be a negative 6x. So it's possible. However, it's easier to get the y's to have opposite coefficients because one of them is already negative and the other one's positive. And all we have to do is multiply the first one of those by a 2, because 2 times negative 1 would be a negative 2y, and then we have our opposite coefficients. So it's easier to multiply both equations by, no, not both equations, the top equation by 2, and we don't have to multiply the bottom equation by anything, and that will result in having opposite coefficients. So to answer question A, you would say I can multiply the first equation by 2 so that the y terms have opposite coefficients. Okay, let's look at B. In B, it says what can you multiply the second equation by so that the x terms have opposite coefficients. So we have 3x plus 5y equals 20, and x plus 2y equals 9. So they're telling us to look at the second equation and to try to eliminate the x terms by having opposite coefficients. So if the top one is a 3x, what do we want the bottom one to be? We want the bottom one to be a negative 3x. So if you multiply both sides of this equation by a negative 3, then you would go ahead and have your opposite coefficients so that you could add them together and eliminate one of the variables. Now C is a little bit trickier because if you look at it, look at the x. 2x and 7x. There's nothing I can multiply one of them by so that it will equal the other one. And they want us to look at the y terms. The y terms, one's positive and one's negative, but one's 3 and one's 8. So there's, again, no number that I could multiply just one equation by. But like I started to do in 1a, we could multiply the top equation by one number and the bottom equation by a different number so that we could get the same but opposite coefficient for the y terms. What could we multiply negative 3 by to get negative 24? We can multiply by 8. 8 times 3 is 24. And I can multiply the bottom one by 3, and that would give me a positive 24. Those would both be y's. So the first equation should be multiplied by 8. So multiply by 8. And the second equation, you can finish writing it, you're going to multiply by 3. And that way you'll get negative 24 for both of the coefficients, and then you can proceed with solving this system by elimination. You'll be able to add them together and eliminate one of the variables. All right, now we're going to look at how to do a whole problem so that you can finish and solve for your variables. All right, so in this example problem, we have 2x plus 1y equals 3 and negative 1x plus 3y equals negative 12. We want to multiply one of the equations, or sometimes both, but in this case we can do one of the equations by a number so that we have one coefficient 2x and one negative 2x. So we can multiply everything in the second equation by a 2. That's what they're doing right here. Every single term has to be multiplied by 2. So 2 times negative x is negative 2x, 2 times 3y is 6y, 2 times negative 12 is negative 24. Now we have this system right here. Now when we add together 2x plus negative 2x, that's 0. The x's cancel. And then we have 1y plus 6y is 7y, and 3 plus negative 24 is negative 21. So then we divide both sides by 7, and we get y equals negative 3. The rest of this is the same as we've been doing in the last few assignments, where once you have one of the variables, you pick one of the equations to plug that back in, and then you solve for the other variable. So the only difference is you have an extra first step where you have to get the opposite coefficients of one of the variables by multiplying either one or both equations in order to do that. So the steps are written down for you for number 2, and it gives you a pretty broad hint on how you're going to solve this one. So I'm going to let you work on that one yourself, and we're going to work on number 3 together. So if you have your worksheet out, you're ready to go. If you don't, pause the video, get your worksheet open, and follow along with me while we do this problem. All right, so let's look at our coefficients. In front of the x term, we have 2 and negative 4. In front of the y term, we have 2 and 4. Either one of those would be pretty easy to multiply and get opposite coefficients, but the x's are the easiest because we have one of them already positive and one of them is a negative. If I want to get them both to be a 4, one would be a negative 4 and the other would be a positive 4, I need to multiply everything on the top equation by 2. So let's do that over here. And the reason I multiply it by 2 is so that we'll get a 4x, and then on the bottom we have a minus 4x, so we'll be able to combine. Everything has to be multiplied by 2. So 2 times 2x is 4x, 2 times 2y is 4y, equals 2 times 2 is 4. Sometimes people forget to multiply the other side by that, but you have to multiply both sides, everything on both sides by that number, or it wouldn't be the same value of an equation. And then we're just going to rewrite the second equation, negative 4x plus 4y equals 12. Now we're ready to add these equations together because 4x minus 4x is 0. It eliminates the x term. 4y plus 4y is 8y. 4 plus 12 is 16. Divide both sides by 8, and we find that y is equal to 2. Now remember, we're not done. Once we know what y is, we still have to find out what x is. You can pick either equation. The top one has a little bit smaller number, so I'm going to use the top equation to find x. I'm going to take what y is equal to and plug it into my equation. 2x plus 2 times 2 equals 2. That's a lot of 2's. 2x plus 4 equals 2. And then I would subtract 4 from both sides, so 2x is equal to a negative 2, and then divide by 2 to get x is equal to a negative 1. So we write it as a coordinate point, just like we did in the last assignments, negative 1, 2, and then we check. So remember, when you check, you have to take the values of x and y, this is x, this is y, and you plug it back into both of your original equations and make sure that you get a true statement. So the top equation would be 2 times negative 1 plus 2 times 2, and we want to see if that's equal to 2. So 2 times negative 1 is negative 2, plus 4. Negative 2 plus 4 is 2, so 2 equals 2, and that is true. Then we have to check it in the second equation. I'm a little bit out of room, I'm just going to do it down here. Negative 4 times 1, 1 is negative 1, plus 4 times y, y is 2, is supposed to equal 12. So negative 4 times negative 1 is a positive 4. 4 times 2 is 8. 4 plus 8 is 12. So we did get a true statement. So that means that our solution of negative 1, 2 is good. It's correct and we have the right answer. Number 4 will be done just like that. The first step will be figuring out what could I multiply one of these equations by so that they would have opposite coefficients on one term. In this one, I think you should be looking at the x terms because we already have 3x. If I could get the bottom one to be a negative 3x, then you'd be all set. So what could you multiply the bottom equation by to get negative 3x? And then don't forget that if you decide to multiply the bottom by negative 3, you have to multiply every term by negative 3. This by negative 3, this by negative 3, this by negative 3. And then you can go ahead and add them together. And then finally, there's a couple problems to solve where you have to multiply both of the equations by a number in order to get your opposite coefficients. So there's an example here to help you out. And then we're going to look at number 6 together. So in number 6, our coefficients of the x are 2 and 7. Our coefficients of the y are negative 3 and 8. Let's look back at a problem that we did together. 2x minus 3y equals 50, 7x plus 8. This reminds me of a problem that we solved earlier with number 1. Look at that. So we already did, in 1c, we already decided that we could multiply the first equation by 8 and the second equation by 3 in order to get the opposite coefficients for the y term. So by doing that, you would get negative 24y and 24y, and then you can add them together and you would be able to find your answer, your x and your x for the first one. So this problem is going to be done using what we just said. We're going to multiply the first equation by 8 and the second equation by 3, just like we decided in problem 1c. So when you multiply the first equation by 8, you have to multiply every single term by 8. So we'll have 8 times 2x, and then we'll have minus 8 times 3y, and that will be equal to 8 times 50. Now 8 times 50 is just like 8 times 5, and then with an extra 0 after it. So that's going to be 400. And then on the second equation, you have to multiply everything by 3. 3 times 7x, that's 21x. 3 times 8y, that's 24y. And then 3 times 10, negative 10, negative 30. And now we can add these equations together. It's all set up because we have a negative 24y and a plus 24y. So when we add these together, the y term will eliminate. So 16x plus 21x is 37x equals 400 minus 30 is 370. And then we divide both sides by 37, and we get that x is equal to 10. And once we know what x is, we still have to solve for y. So pick one of your equations. It doesn't have to be the top one. You might decide the bottom one is easier. And you replace x with 10, and then keep solving your equation until you are able to figure out what y is. 2 times 10 is 20. And then we would subtract 20 from both sides, and we would get negative 3y equals 50 minus 20 is 30. and then you will divide by -3, and you'll be able to figure out what y is equal to. I'll let you finish that up, and then write it as a coordinate point, and then check your answer and make sure that it works. So there's not a lot of problems on this worksheet, but they do take a little bit of time. Make sure that you do them carefully and check your answers. Thank you and have a wonderful day.